Now let's move on to question number 5. In a hydraulic machine, the two pistons are of areas of cross section in the ratio 1:8. Calculate the force needed on the narrow piston to overcome a force of 1600 Newton. So let's solve this question. So it is given that A1 is to A2, that is 1:8. ये हमें already question में provided है. The area of cross section, it is in the ratio 1:8. And it is also given that F2 is 1600 Newton. So what do we have to find? We have to find F1. Okay, narrow piston में कितना force needed है? Calculate the force needed on the narrow piston to overcome the force of 1600 Newton. So we need to find F1. So we are going to apply the principle of hydraulic machine. So by the principle of hydraulic machine, we know that pressure on narrow piston will be equal to pressure on wider piston. Now let's put the formula, that is F1 by A1 is equals to F2 by A2. So we need to find the value of F1. Okay, so we'll write it as it is, F1. Next, A1 is provided to us, that is 1. F2, it is also provided to us, that is 1600, and A2 is also provided to us, that is 8. So therefore, F1 will be 1600 by 8, that is 8 ones are, and 200s are is 1600. So your F1 will be 200 Newton. So 200 Newton is the force needed on the narrow piston. So this is your answer. Now let's move on to question number 6. What is the length of water column that corresponds to the same pressure as 76 centimeter of mercury column? So let's solve this question. So we know that pressure at the place remains same for both mercury and water. Okay, now let's consider mercury first. So the pressure exerted by mercury will be the density of mercury into height of mercury column into gravity. Now we will be substituting the value. Density of the mercury is 13.6 gram per ml. Height of mercury, it is given to us in the question, that is 76 centimeter. And we'll write gravity as it is, that is G. Now let's move on to the pressure of water. Pressure exerted by the water will be again density of water into height of water column into gravity. Let's substitute the value. Density of water is 1 gram per ml. Height of the water column we need to find out. And gravity we'll write as it is. Okay. So according to the question, the pressure exerted by the mercury will be same as the pressure exerted by water. That is 13.6 into 76 into G will be is equals to 1 into H into G. We need to find the value of H. Okay, so G and G will get cancelled. We need to find the value of H, that is 13.6 into 76. And it will be equal to 1033.6 centimeter. So that will be the height of water column.